Alright, next up we're looking at Objective 54, which is simplifying radicals with variables. Before we jump into simplifying radicals with variables, I want to simplify a radical that doesn't have variables. So this we should already be familiar with, the square root of 80. Again, 80 is not a perfect square, so we're going to have to break it down and use the jailbreak method. So looking at the square root of 80, we can break it down into the square root of, say, 10 times 8. You could say 4 times 20, 16 times 5. Any of those factors are fine. We'll continue breaking it down until we can't anymore. 10, we can break it down into 5 and 2. 8, we can break down into 4 and 2. And we can break down 4 even further, and that becomes, let's see, this would be 2 and 2. So we have 5 times, and then 2 times 2, and then bring down that last 2. Okay, the jailbreak method, we find partners and we bring them out. So we have a pair of 2's. We have another pair of 2's. We can bring them both out. So on the outside, we have 2 times 2. On the inside, we have the square root of 5. We evaluate 2 times 2, and we get 4 times the square root of 5. So now let's talk about simplifying radicals with variables. So this is the definition, simplifying radicals with variables. And really it's not all that different than simplifying radicals with numbers. In fact, we're going to say that it is, conceptually, it's the same as simplifying radicals with numbers. And what do we mean by that? Well, if we're using the jailbreak method, we're saying pairs get to escape. So let's take a look at an example. If I were to give you the square root of x to the third power, or x cubed, we know that x cubed can be rewritten as x times itself 3 times. So x times x times x. From here we can pull out our pairs. We can find partners, so we can pull out a pair of x's that comes out to the front. So what's left over? We have one x out in front, and what's left over inside is just x. So x, the square root of x cubed, can be simplified to x times the square root of x. Let's take a look at a few examples. Here we have the square root of a to the 6th, b to the 5th, c to the 10th. So if I were to write this out, we know that a to the 6th is a times itself 6 times. So a times a times a times a times a times a. B to the 5th is b times itself 5 times. So b times b times b times b times b. And then c to the 10th is c times itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, pairs get to escape. So we're going to start taking out pairs. Let's just go letter by letter. So I see our A's. Let's circle our pairs. So we have 1 pair, 2 pairs, 3 pairs. So these 3 pairs can come out front. So already I can write out front A, A, A. So 3 A's. Looking at our B's, we circle our partners. We have 2 pairs, and there's 1 left over. We'll talk about what happens when there's 1 left over. But we're going to pull these 2 pairs out. So on the outside, we have 2 B's. And lastly, we have our C's. So we have 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, and there are none left over. All 5 of these pairs get to be pulled out front. So we have 1, 2, 3, 4, 5 C's. And then what's left on the inside? All that's left on the inside is just that 1 lonely B. Right? We know that a times a times a, or a times itself 3 times, can be rewritten as a cubed. B times itself twice can be rewritten as b squared. C times itself 5 times can be rewritten as c to the 5th. And then our square root of b. And this is our final answer. So of course this always works. You can always rewrite your exponents as a bunch of factors, right? But if I were to give you a to the 100th, this would become a little bit tedious to write out 100 a's. What do we recognize as the pattern? So how do we go from a to the 6th to a to the 3rd out front? Well, and how do we get from c to the 10th to c to the 5th out front? You may have noticed that we have, if we take the 6th, in order to get to 3, we have to divide by 2. So 6 divided by 2 gives us 3. So when we divide by 2, we get that power on the outside. Let's try it for the b to the 5th. So we take that power, we divide it by 2, and what happens when we divide 5 by 2? We get 2.5. So we have 2 b's that come out, and then since this doesn't come out evenly, the 1/2, that stays inside. That tells you that you have 1 b on the inside of the radical. So 2 come out and 1 stays in. And then for c to the 10th, we have 10 divided by 2. That gives us 5. So 5 comes out. There's nothing left over, so nothing stays inside. So that's where we get that c to the 5th. Let's try this one here. Here we have 60, x, y to the 8th, z to the 11th. So let's write that out. We have square root of 60 times x. Well, what's the exponent for x? There's nothing written, so when there's nothing written, it's just 1. We have just 1x. And then we have y to the 8th. So when we write that out, we have 8y. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have 11 z's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So taking a look at this 60, we got to break it down just like we normally do with our jailbreak method. So 60 can be broken down into 4 and 15. We could bring down the rest. I'm not going to rewrite it. We can continue to break this down. So we have 4. It's broken down into 2 and 2. 15 gets broken down into 5 and 3. And then we can bring down the rest again. Let's start pulling out pairs. So our 60 is 2 times 2 times 5 times 3. And then times x times 8y's and 11z's. So pulling out pairs, our 2's, they can come out front, so we have a 2. And the 5 and 3 stay on the inside. Our x's, there's no pairs, there's no partners, so that stays on the inside. Our y's, we have 1 pair, 2 pairs, 3 pairs, 4 pairs, so those 4 can come on the outside. So we have y to the 4th. And then we've also got our z term. Grab a different color. So we have 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So 5 z's can come out, and there's 1 left inside. So finishing up this, what's left over inside? We've got a 5 times 3 is 15. We've got an x. We've got a z. And this is our final solution. 2 y to the 4th, z to the 5th, times the square root of 15 x z. So how can we get that from here? Well, the 60, we have to do the jailbreak method either way. For the numbers, you have to break those down as you normally would. But for the variables, we can use that exponent trick. So here we have x. The exponent is 1. So when we divide by 2, we get 1/2. So that doesn't divide evenly, we just get 1/2. That tells us that we have 1 left inside. Looking at our y to the 8th, we have 8 divided by 2. That is 4, so that tells us 4 comes out, there's nothing left over. So just 4 comes out and no y's on the inside. And then we've got 11 divided by 2. That gives us 5.5. So that tells us we have 5 that come out, and 1 of them stays inside. So 5 z's come out, and then 1 stays inside. We're going to continue to get a lot of practice on this, so go ahead and review your notes and we'll practice.